Hey, welcome everyone. I'll have a few notes about the final here at the beginning few minutes of class. While I'm talking about that a little bit, you can think about what questions you might want to have for me as far as today's activity is concerned, or maybe you've had a chance to look at the review a little bit. The final exam is scheduled for Friday. And for most of you turning in now, this is my 3:45 class. Your exam is 7:45 a.m. If you're a holdover from the 2:15 class, yours is at 12:45. And that is after lunch. Thank goodness no one wants to get up in the middle of the night. Question 3, sure, Matthew, we'll do question 3 in its entirety. Right. Now, there's a little bit on question 3. I was going over it with my early class where the antiderivative is not obvious. But after through the antiderivative question, the last one should make sense based on what we did on the last exam. So the last question, question 3, was the stuff we did on the last exam. Anyway, this is our final exam schedule. If you absolutely cannot make it during your class time, do let me know and make sure that it opens up at another time as well. I will have some review sessions coming. Oh, by the way, it looks like it's going to be 40 to 45 questions, and I'm pretty sure the whole thing is going to be multiple choice. I was in contact with the course coordinator earlier today. She didn't have all the details hashed out, but she says she's been working on it, and it's pretty well in hand. I'll make sure on these details as the week progresses. We do have some review sessions scheduled. I've scheduled those for, let's see, I guess tomorrow's Wednesday, 1 o'clock, Thursday, 1 o'clock. And then for those of you who are in the 7:40 or the 2:15 class taking the exam Friday afternoon, I'll have one more session. I think I scheduled that for 10:30, yeah. 10:30 a.m. on Friday. So that'll be those of you taking the final exam at 12:45. You'll get a couple questions in that you can ask me then. My idea is to cover the first half of the material on Wednesday, and I'll probably see if I can just go through that in straightforward question by question by question. And I'll do the same thing on Thursday, the second half. That way, it's indexed, and if someone has questions and they're not able to watch the live feed, they'll be able to open up one of those two and then figure out where their question is, and then watch me work through it and maybe get their questions answered that way. So that's what's coming up the rest of this week. Today we're going to look at the activity, and we already have question 3. So let's look at question 3 on today's activity. I was hoping you were on one of today's activity, Matthew. Let me know if it was the review packet. And by the way, let's see if you can get these things turned in maybe by the end of today. I've lost some of my graders. Some of them have their own finals to work on, and my eyes can't handle a whole bunch at once. So if I can do a few today, a few tomorrow, a few Thursday, that would be good. Okay, the activity it is. That's what I expected. All right, so let's take a look at that activity. And I've again given you a marginal cost function. So that was much like a question that you had on the exam. In fact, this was probably the one question that I wanted to look at as far as the exam was concerned. That's why I included it on here. So then we have the marginal cost. We want to come up with the cost function, the cost being the antiderivative. So we have the marginal cost, the cost function C of x will be whatever this thing comes out to be with the appropriate constant at the end. So we have 500x plus 100 to the negative 0.25 dx. Finding the antiderivative, C of x is equal to, I'm going to keep the 500, I'm going to keep the base, I'm going to raise the power by 1, and I'm going to multiply by the reciprocal of that new power. Now this one is slightly different than ones we've done in the past. This one technically might require the integration by substitution. In this case, the integration by substitution didn't really add anything to it. So, just sort of take my word, I guess, on this part of it. All right. I'm going to add some plus k at the end. Now let's do that division. 500 divided by 3/4. Looks like that's about 667 times x plus 100 to the 0.75 plus some number k. Now we have to figure out what k is. Now the initial condition was the fixed cost is $2,500. So when we're producing 0 units of goods, we still have expenses of $2,500. So when I plug in 0 for x, this whole result on the right-hand side has to be $2,500. So 667 times 100 to the 0.75 plus this k, that has to be 2,500. The k is not automatically 2,500. I think it worked out that way one time, maybe two, on the activities we did in class. In all the other cases, it worked out to be something else. So, yeah, and there's one question where we did pretty much this exact problem on the last exam. Almost all of you got the correct antiderivative, but very, very few of you got the right value for that constant at the end. So let's evaluate this. I have a little bit on my calculator here that's going to help me out, I think. Let's see, 667 times 100 to the 0.75. So it looks like this is a 21,092. Subtract that from both sides, and it looks like k, therefore, is going to be a negative number. Negative 18,592. There is the cost function. Now remember, the cost function has to do two things. It has to be such that the marginal cost function is this. And if you bring the power down, reduce the power by 1, multiply by the derivative of the inside function, you will indeed get the 500x plus 100 to the negative 0.25. And the other thing is, when you plug in 100, that result has to be 2,500. So plugging in, when you plug in 0. When you plug in 0 here, you get 100 to that power. That's 21,092 minus 18,592. Do that subtraction, and you get 2,500. So that was one of the big errors. Just, that constant at the end isn't necessarily the initial condition. So watch that carefully, because there will be one on the final. I can't say that for sure. I'm not writing the final, but every time in the last 6 years, I think since we started teaching this in the flipped classroom design and shared the final exam, I think every time there's been one of these on the final, and the constant at the end is not the initial condition, isn't the z of 0. So, don't just assume that that's the number that gets tacked on. That costs a lot of you a lot of points on that last exam. By the way, the last exam was done really, really well. My opening class, my 215 class, had a median score of 87 and change, and this afternoon class was 81. It was a little bit lower, which is unusual. Usually my second class does a little bit better, but tables were turned on that exam. Okay, part B, find the cost of manufacturing 600 mowers. Well, we have the cost function here now, right? There's the cost function. We know the cost of plugging the 0 in. We know that's negative 2,500. So we just plug the number in there. So the cost of 600 mowers, whatever C of 600 is. Next part, find the cost of manufacturing 800 mowers. Now, whatever that is. You have the cost function there. It should be easy to do. All right, on to part D. How much extra did it cost to move production from 800 to 600? Whatever you got here, whatever the cost of manufacturing 800 was, subtract from that the cost of manufacturing 600. That's how much it moved. This is how much it cost for 800. That's how much it cost for 600. The difference between the two is how much it costs to move production from one level to the other. And now we have that next antiderivative, part E. Look at that. It's the area under the curve, and the production levels are from 600 to 800. So yes, that will be exactly the number of dollars it costs to move our production from, and it's shaded, no, it's not shaded on the graph. It would be equivalent to the region under the graph between 600 and 800. So let me get a little better look at my marginal cost function. There we go. Graphing-wise, it would be that, and word-wise, it would be the cost in dollars. Remember, this is dollars per unit manufactured. That's number of units. Area under the curve is the, I'll write that up here. This is dollars per unit, and this number of units manufactured. When you multiply those two together, the units cross-cancel, and you're left with dollars. Area under the curve will be the number of dollars. In this case, it's the number of dollars to move production from 600 to 800. Okay, and you already know what that is. You had that problem in part D. That's the same question. Calculate the definite integral from part E. Okay, so from part E, we're going, yeah. So we should get exactly the same thing. The answer to part F should be exactly the same thing as we had on part D. This definite integral tells us how much it costs moving from one to the other. Describe the area of the shaded region in the context of the problem. That would be the dollars it cost to move production from 1,000 units to 1,500 units. So that's, I guess, part EFG. I guess that's part G without the G there. So part G is the amount it would cost to move production from 1,000 to 1,500 units. Right. So there it is, all the stuff from before. Excellent question. It'll help us out in the final because there will be a couple of the conceptual type questions there that, if you understand the concepts there, the hard problems there, we're taking the antiderivative, but if you understand the conceptual ones, like what does this represent, what's the area under the curve, how do you describe this definite integral, if you understand those are the questions that you should be able to go through on the final exam. Mark your answer, know you have it right in about 5 minutes, about 5 seconds. The calculation ones will take you a little longer. This exam used to be 50 questions, multiple choice, and hardly anyone had any trouble getting through it. Typically there's 20 questions or so, like these conceptual ones, maybe some of the early limit ones where you can look at the problem and know the answer. There are probably 15 or so that require a little bit more work, and then there's probably another 15 or so that would require some fairly serious calculations, and they take up to 5 minutes apiece. But no one ever had any trouble. Very few people, I should say that. Very few people ever had any trouble finishing. Typically, all of my students, or all but one of them, were gone before the 2 hours and 15 minutes ended. And since this semester's exam is a little shorter than the previous one, I'm guessing that's going to be the case as well. And again, I'm guessing this is 40 to 45 questions, multiple choice. So there's not going to be this situation where I'm going to be sitting and grading a whole bunch of these and worrying about partial credit. So there's question 3. What's the next question we have for today? Number 1, okay. Good place to start, as always. So number 1, I had a problem very similar to on the video guide. have supply curve, demand curve. Both of those are concave up. Supply curve is here, demand curve is there. Supply curves always go uphill as you go from left to right. The supply goes up. Here's the price on this curve. Here's the supply on this curve. As the price goes up, the supply goes up. Demand curves work the opposite way. When the price is really high, there's very little demand. As the price comes down, the demand, the number of units demanded down here gets bigger and bigger. So this is sort of the consumer side, and this is sort of the producer side. Shade the area for the consumer surplus. Well, we have some consumers who'd be willing to spend a lot of money, not very many of them, but we have a lot of them that will be there. They don't have to because the price settles in here at, I'm going to call that P hat. I think that's what MyLab calls it, the equilibrium price. So there's a whole bunch of dollars here. Remember, this is the price, dollars per unit, and this is the number of units sold. So this represents, this area in here represents dollars. This is the dollar saved. Some people would be willing to spend a whole bunch of money, but they don't have to. And hopefully by the end of today, I'm going to remember this. I promised it to my early class. But there's a nice story I have to tell about how producers tend to try to soak this up at the beginning of a production. I'll show you what that is in a little bit. They don't want, here's money that they could have in their pockets. They don't want to necessarily give it away. So there's the producer surplus demand curve for consumers. There's a consumer surplus. Here's the producer surplus. We have some people who, for a very low price, would make this a particular good. They don't have to make it for such a price because the equilibrium in the market determines what the price is going to be. The equilibrium price is higher than what they would be willing to produce it for. So they get extra money in their pockets. So right there is what we're going to call X hat. That point right there is the equilibrium point. That's where everything tends to balance out, at least as far as economic theory is concerned. So we're going to have to find the area under this curve and above the price equilibrium point. We're going to have to find the area underneath the equilibrium price, but below the above the supply curve for the producer surplus. So there's the producer surplus, and here's the consumer surplus. We're going to find both of those areas. Both of those areas will measure dollars. We're going to find both of those areas by using calculus. In order to find how to set up this integration, we necessarily have to find that point. So in order to find where those two graphs cross, as always, we'll set those two functions equal to each other. 50e to the 0.02x will have to equal, I believe that was 1,000. Yeah, e to the negative 0.012x. So setting those two equal to each other, we have a few steps going on. What I notice on this one is I have x's on both sides of the equation, and that's never good. I could, if I chose to, rewrite this as e to the 0.012x in the denominator. And if I do it that way, that lends me an idea as to what to do next. I don't like working with fractions. Negative exponents are messy enough. So what I'm going to do to both sides of this function is get rid of the fractions by multiplying both sides by e to this 0.012x power. I'll try to squeeze it up here. If you can't see it, it's just that it's that same power both sides. Well, here they cross cancel. And on this side, we have e to two separate powers multiplied together. And the power rule says if you have like bases multiplied together, you add the exponents. So 50e to the 0.032x is equal to 1,000. Now we're back to the exponential type of equations that we've been solving pretty much all semester long. Same basic steps here. Divide both sides by 50. E to the 0.032x is equal to 20. And now we have a missing number in the exponent. The only way we can get that is to use the logs. The log asks us what the power is. We want to know what power e is to give us 20. That's what natural log asks us. Natural log of 20 is the power of e that gives us 20. So this power right there, 0.032x, that power must equal the natural log of 20. Grab out your calculators if you would, please, and let me know what x is. At least round it to the nearest whole. That way we don't have to carry a whole bunch of decimals through. $94 it is, yep. And if you look at the graph, you can tell that that's just right at 94. So that's a nice thing to have, those graphs listed right there. And it looks like the equilibrium price has got to be somewhere between 300 and 350, I would guess. Let's see if we can find the equilibrium price next. Now I did this, there's some rounding here. So when I plug this 94 back into the producer and in the consumer surplus, back into the supply and the demand curves, they're not going to necessarily exactly agree. There's going to be some rounding error. So let's do it in both and we'll sort of move between the two. So the supply curve, S curve, that'd be 50 e to the 0.02 times 94. Tell someone work that on the calculator. Someone else, let's work on the demand side. The demand curve would have been 1,000 e to the negative 0.012 times 94. So there's my supply curve, there's a demand curve, both of them plugging in that 94. Let's see what values we get, and then we'll sort of split the difference. The supply curve, 328, okay. That seems to be reasonable based on the picture I saw, where that height was. Demand curve of 324, okay. So let's split the difference. Let's say that the P hat is about 326. Again, the rounding error threw both of those off a little bit, but we're not going to quibble between $1 or $2 in the long run of this problem. It's all approximate anyway. So here we go. Consumer surplus first. That's this area under the demand curve and above this price. So we're going to integrate 0 to 94. There's our limits of integration, 0 to 94. The demand curve was 1,000 e to the negative 0.012x. This equilibrium price was 326, and we'll integrate that dx. The last exam showed that most students were really good with this type of a problem. So let's do the antiderivative. We'll keep the 1,000. We'll multiply by the reciprocal of that derivative, negative 1 over 0.012. Keep the e, keep the same power as we had before. There's the first half of my antiderivative, and then the second half is a little more straightforward. The antiderivative of 326 is 326x. One more time, grab out the calculator. Let's see what we get for the 1,000 divided by the 0.02. 8333. Okay. So this is negative 83,333 e to the negative 0.012x minus 326x. There's the antiderivative. So we have 2 steps left on this one. Well, I don't know. How many steps are you going to count it? We're going to evaluate this at 94. So someone get busy, evaluate that at 94. And we're also going to evaluate that at 0. I'll do the 0 part. If I plug in 0, that thing goes to 1, that goes to 0, so this is negative 83,333. Someone plug in the 94 in for x in our antiderivative. Remember, that's both negative and that's negative. Let me know what you get when those 2 calculations are done. It's also got to be a negative, doesn't it? See that already? So again, we're going to evaluate this for 94. What do we get when we plug 94 into our antiderivative? Negative 57,617. Good. Thank you, Tommy. Minus negative 83, blah, 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 is 25,716. I like it. That seems familiar. You guys have the advantage of we worked through these hour and a half ago. So that's the number of dollars that consumers get to save because they don't have to spend as much as some of them would be willing to spend. They just have to spend the 326. And you'll find in the producer surplus, the number comes out to be probably a little smaller. I think that area is a little less than that. I'm going to put this up here just. It might not look like it on this graph, but when I looked at my activity, I'm going to look at it one more time. Yeah, it's quite a bit less. So let's work through the producer surplus, shall we? The producer surplus, there's some people that are going to get $326 for producing this good, even though they'd be willing to produce it for quite a bit less. They get a little extra money, make a little more profit. Let's figure out all the dollars that the producers are going to make that more than they'd be willing to make. Again, it'll be a definite integral. Again, the limits are going to be simple. It's this green area here. The limits on integration for x are 0 to 94. We'll take the upper curve minus the lower curve. The upper curve in this case is a 326. The lower curve is the supply curve. And I think that was 50 e to the 0.02x. I better make sure. That seems right, though. Yep. All right, one more time, the same basic steps as we did last time. The derivative of, or antiderivative of 326 is again 326x. We'll do the same steps, getting the coefficient here. It's minus 50 times 1 over 0.02. That's 200ths, that's 1/50th, that's 2500. E to the 0.02x. So 326x, and someone would get busy on the calculator, I'd appreciate it again. This is 2500, I believe. E to the 0.02x. And one more time, we're going to evaluate this from 94 to 0. And again, one more time, I'm going to do the 0 part because it's easy. Plugging in 0 here makes that 0, makes this negative 2,500. So I'm going to subtract off negative 2,500. Someone let me know what you get when you plug in the 94 for the upper value for that function. Total, okay, Matthew's 2 steps ahead of me, has a total of 16,760. And that just seems to ring a bell. 16,760. And yeah, that's significantly less than the consumer surplus. I could tell that the area was significantly less, about a third off. So I'm willing to leave it at that. If someone else has someone else and wants to throw that first number in, I don't really care. Happy with that? Any more questions on problem 1? So let me know via chat. If not, let me know what I can do next. While you're putting the finishing touches on this one, I'm going to step aside and get a quick cup of tea. I'll be right back. Left to right where we left it. Oh, I'm waiting for the next question if there are any more. I want to get to sort of the Business Insider idea as to what companies do, especially if they have a monopoly. I mean, if you have people willing to spend that much on your product and you're only going to charge them that much, I mean, there's money you're losing. And what sort of a business person would want to do that? So a few years ago, okay, it's been I'm an old guy. I'm 60-some years old. I'm so old I can't even remember how to subtract the numbers. But back in the day, when I was early 20s, it was the dawn of the revolution in musical recording. Before that, it was pretty much LPs and cassette tapes, and they were starting to go out of style because the latest thing on the market was the CD, the compact disc, and they came on the market with a lot of fanfare. I remember the original one. I had a nice stereo system at the time with components like everyone did back in the 70s and early 80s. Turntable and tape deck and amplifier and preamp and tuner and nice speakers. And it was all built out. Anyway, this was the newest thing on the market. And the original price for the compact player was $2,500. So why was it $2,500? Well, there were only two companies that were licensed to make it. I think Philips Magnavox and Sony. They had the patent rights on this compact disc player, and they could pretty well set the market any place they wanted to set it. So what they decided to do was set it at the very top of the food chain, so that way those people who were willing to spend, here's what I was willing to spend, maybe a couple of hundred, but there's some folks up there willing to spend $2,500. So they priced it at $2,500. They kept the supply really short, and they sold as many of those for $2,500 as they could. And then they lowered it down. Maybe it was $2,250, or maybe down to $2,000. When my brother and I were in the store trying to decide, it sounded great. There are no scratches anymore. No tape hiss, no wow and flutter. It sounded so much better in many aspects. They're a little more durable. It finally came down right around $1,000. This was maybe on the market a year and a half or so, and that's when my brother decided he just needed to get one. So he shot it. And the funny thing is, we were in the store and we were talking to the sales folks, and they said, "Oh, this is about as low as this price is going to go." The stuff that goes into it, the laser readers and the diamonds. It's labor intensive to put this together. There's no way that's going to come down to $79.95, which is a typical joke, because you could go into Sears and buy any sort of audio equipment you wanted. Every piece was $79.95. So he says, you're never going to see this in the store for $79.95. So my brother jumped in and bought it at $1,000. I was a little more reasonable than he was. I'm the older brother, the one that takes a few less risks, I guess. So I'm not willing to spend. And a year later they were down to $500. A year after that they were down to $250. Now my brother bought his on payments, and he was about, I think, he had maybe paid $750 or so out of the $1,000 when the store he bought it from went out of business. So he ended up paying $750 for it. About a couple years later, I think I spent $125. And sure enough, about 5 years later, they were for sale on Sears for $87.99 or whatever the Sears price was. But what they did is they were clever. That was the demand curve. They milked as many of those 2,500 people as they can, then as many of the 2,250, and then many as 2,000, and then 1,900, 1,800, 1,600. Finally, it bottomed out, and then also after a few years, the rest of the industry was able to jump in and make them. And gosh, I don't know what you can buy one for, $13 maybe now. But that's sort of where, if you understand this economics and you have a system where you can, start up high and let the price drop, that's what you do. And you see that so often, right? Anytime a new technology kicks in, as long as, there's not a lot of competition in making that, they're going to start milking the consumer for every dollar they can. Look at cell phone prices, for goodness sakes, way back when they were brand new. All right, so that's my little story as to as a business person, if I had a choice, wanted to make a lot of money, I'd start with prices high. I guess Tesla sort of does that, right? They started with the really high-priced automobiles that have a huge margin. Not many people could afford the Model S or Model X when they first came out. They drop them down, and they finally get where someone is a little more affordable. You see that all the time. Okay, problem two. Now, problem two has one or two little different things. I'm going to rewrite the functions up here in a slightly different form. Again, we need to find the equilibrium quantity and price. So let's set those two equal to each other and see if we can find the equilibrium quantity first. Now I'm going to rewrite this. It's x to the 0.5 power, which is 1/2, which is also the square root of x. And I find that students conceive of an answer better if they see it in this form. So the first thing is to get the equilibrium price. Notice both of those are to the 1/2 power. So both of those are square roots. If I ask you to solve this equation, what might you want to do first? So remember what those are. Those are both concave down, I think. And I think the bottom one is going to be a little bigger. Yeah, multiplied by the reciprocal. Yeah, okay. So the reciprocal of the square root is the square power. So to undo a square root, let's square both sides. So this is 60 times the square root of x times 60 times the square root of x, 3,600 times x. This is 80 times that square root times that square root, 6,400 times 50 minus x. And now we're back to a simple linear case. We don't have any squares. We don't have anything except for single power, or x to the first power. So distribute through, gather up your like terms, solve for x. What should x equal? And it looked like on the graph. I'm going to look one more time. I remember it being, let's see, 5, 10, 15, 20, 25, 30, somewhere between 30 and 35. And the price looks like it's got to be about 325 or so. So this guy's has to be somewhere between 320 and 350, I think. And this has to be somewhere between 30 and 35. What do we get for that value of x? For the quantity demanded, what do we get for the value of x for the equilibrium quantity? I think the math lab called this x hat. And they called this p hat for the equilibrium price and the equilibrium quantity. So what is that equilibrium quantity going to be when you solve that equation? Yeah, 32 it is. So as always, we're going to take that 32 and plug it in, probably both. That'll make sure we don't mess up the calculations at all. So if we get the same answer, and since that came out even, we should get exactly the same answer on this one. So 60 times the square root of 32 should be the same thing as 80 times the square root of, let's see, 50 minus 32 would be 18. Both those should come out to be the same number, and that number should be your p hat. Let's get that rounded to the nearest dollar per unit, please. So plug 32 in for either the supply or the demand function. And remember, again, these are dollars per unit produced, and these are number of units. That's the demand quantity, and the demand price, price per unit produced or sold. 339, and that seems right on looking at the graph. Okay. So now let's set up both the consumer and the producer surplus. There's a consumer surplus. Here's a producer surplus. Let's go with the consumer surplus first because that's on top, and I like working top down. That's the way my brain thinks the best. All right, so here we go. 0 to 32, those units. This curve, or that area between those two curves. The demand curve was that one that's starting high and going down. So that was the 80 times the square root. Yeah. I'm going to rewrite this as 50 minus x to the 1/2 power minus the 330. Is it 336? 339. Okay. Follow that as always with our dx. Check one thing here. Let's make sure I got those numbers right. Yep. 80 times 50 minus x. Yeah. So here's where we have just a little trouble with this antiderivative. And as I said earlier, since we've dismissed that, there's a couple sections that we just skipped over. We didn't do integration by substitution, and this one would sort of require some of those characteristics. Don't worry about something like this happening on the final. I'm just going to tell you what this antiderivative is. We're going to keep the 80. We're going to keep the 50 minus x. We're going to raise the power by 1, so now it's going to be 3/2 or 1.5. We're going to multiply by the reciprocal of the new power, 1 over 1.5. And since the derivative of this inside function is a -1, we're going to put a negative inside in front of that as well. So that's one thing you would have learned had we done the integration by substitution method. It just has that one extra negative involved in it. Okay. I'm going to subtract from that 339x. I have my calculator out. I can do the 80 divided by 1.5 for you. And that's, do that right? I guess so. 53. Yep. So -53 times 50 minus x to the 1.5 minus 339x. We're going to again evaluate this at x equal to 32 and at x equal to 0. Now in both cases here, we're going to have some work to do. I can't look at either of those and figure it out. So someone would like to plug in 32, tell me what we get. Someone plug in the 0, tell me what we get. And we can do that subtraction later. It looks like, again, these are both going to be negative, doesn't it? Yep. So it's negative something minus negative something. Someone work on first half, plug in the 32, tell me what you get. And then someone else plug in the 0, tell me what you get. Okay, 17,895. That was probably negative in front, right? Yeah, 17,895, I see it. And this next one has to be probably a little more negative. Oh, okay. Negative 14,895. Or was it? Were you telling me, Matthew, that was for the second one? So we have some serious problems here because this one has to be more negative than the first one. It just has to be. Okay, negative 18,738. All right. So do that addition, you'll get what? Not quite 4,000, 3,000 and some. Right. So there we have the consumer surplus. Producer surplus is a little more straightforward. So producer surplus comes up next. Again, the limits on integration are going to change. We're still going from 0 out to the equilibrium point. Now we have the upper function, which was 339, minus the lower function, and I forgot what that was. It's a little simpler one. 60x to the 1/2. Okay. 339x, easy enough, minus 60, raise the power by 1, multiplied by the reciprocal of the new power, 339 minus, 339x minus 40x to the 3/2 power, evaluated one more time between 32 and 0. Gosh, this one's a whole lot easier, isn't it? I'll evaluate the 0 one, you get 0, nice. So someone plug in 32, tell me what you get there, and we will have the producer surplus in one fewer step, huh? I'm going to look back at that picture. I thought that this was the smaller of the two. Let me double check. Oh no, this has got to be bigger. Yeah, there's definitely more area. Trying to cross there. Yeah. Oh, I wrote myself a note on the board, didn't I? 11. Yeah. So this is 11,000. The other one will only, what, 5,000 and something. I almost doubled the area. Oh, 1105. Huh. It makes me wonder a little bit. The other one was 5,000. This is only 1,000. I'm gonna run through. Yeah, okay. Thank you. Yeah, that looks a little better. Yeah. 3607. All right. I like it. I think. I don't know. I didn't bring the answer key with me. You know what? Hang on a second. I might have it open here. I had it open earlier. I do. Yep. 3607 is correct, and the 3935 for this one, if you round it, depending on how you round it. So those areas were closer than I thought. Okay. Spot on. Good to know. Yep. Got it. Both of them solid. And that one is what, slightly bigger than the other, is that right? Ah, producer surplus is bigger. Okay. Guess my eyes are off a little bit. That's everything, right? I think we've done every single part of every single question from beginning to end. Huh? It seems like this is a good way to wrap things up. Just a nice, simple exercise that doesn't combine a whole lot of stuff. I mean, we've been doing area between curves. That was our last material. This just adds maybe one level of intrigue to it. Gives us a nice little chance to take a deep breath after last Thursday. gather a little spirit, get ready for the final that comes up on Friday. One more time, I'll put those review sessions up on the board in case you missed it at the beginning. So I will be coming to you live from this very room, if the math gods allow it, Wednesday, 1 p.m. I'll do the first half of the review packet. Thursday, 1 o'clock p.m. I'll look at the second half. I'm guessing that hour and a half both days will probably give me enough time to get through the majority of it. If not, I'll spend a couple extra minutes somewhere along the line. Any more questions? No quiz today because there's no new material. Know when the exam is for your class. Make sure you can take it with the rest of your class, or if you can't, make sure you let me know so I can revise the schedule to open at a different time. Anything else, anyone? Look forward to hearing from you via chat sometime tomorrow or via email a little later tonight. Until tomorrow then, I'll bid you goodbye. You're welcome. My pleasure as always.